Hi all. So today we're going to talk about confidence intervals. So first things first is to get a sample. So this sample is a small subset of a larger population. And the whole idea is from this sample to draw inference on the population, on some particular metric of interest. So note that it's critically important that your sample must be representative of this larger population for your results to be valid. So first, I'm going to show you the equation and the confidence levels C and the critical value Z, and then explain it all. So the sample mean. So this is the average on the metric that you're looking for, just based on your smaller sample. And this is a great place to start. It's likely that your sample mean will be somewhat close to the population mean, but it's likely that you're not going to get it exactly right. Very probable that you're not going to get it exactly right. It's likely that your sample mean is either going to be a bit lower than the population mean, a bit higher than the population mean. And really what we're doing with these confidence intervals is creating an interval where we believe that the true population mean is. So really it's saying we are 90% confident that it's in between these two numbers, or 95% confident that the true population mean is in between these two numbers, or 99% confident. Those are the three ones we use the most. 95 probably being the most common in psychological science, but this might change from field to field. So depending on the amount of confidence that you want to have, being 99% confident that it's in the interval, 95% confident, or 90% confident, you're going to use a different critical Z value. So in the example we're going to show later, we're going to use a 95% confidence interval, so we'll use the 1.96. And then also important is the population standard deviation that measures how much variability is in the data. And then also the square root of n, so the square root of the number of participants. So now let's do an example and plug all of this in. So in this example, the average weight of a sample of 49 adults is 178 pounds. The population standard deviation is known to be 2 pounds. Create a 95% confidence interval for the population mean. So first things first is we have our equation and these critical values, and then we plug all of these numbers in and solve. So the sample mean is 178. The critical Z value we're going to use is 1.96 because we're using a 95% confidence interval. The standard deviation of the population is 2. And the amount of participants we have is 49. So once you crunch all the numbers, you get 178 plus or minus 0.56. So basically what we're saying is we're 95% confident that the true population mean will be between 178 plus or minus 1.56. And those numbers are 177.4 and 178.56. So to read it all out, we are 95% confident that the population mean is between 177.4 and 178.56. So that's how confidence intervals work. Thank you for watching.